Oh, mic is not working at all. Oh, okay, now it works. Can you hear me? You cannot hear me? Right. Can you hear me? All right. You see, there's a pin issue here. Let me try to not walk around, which is going to be really challenging for me because I'm somebody who would like to walk around. Okay, I'll just talk like this. Oh, maybe I can. Okay, so just let you know, this afternoon discussion, I'm going to talk about the small program. Since all of you, or most of you have ESID now, so we can do this small program, which is count to 20% of your grade. So I'm going to introduce that this afternoon discussion now. So in case you're not aware of, I actually did a recording already uploaded about homework 3 reference implementation, like a line by line for those of you who try to get some help to understand, because it's very critical for you to really understand pretty much every single lines of code there. It's learning the language, but also learning the way they're using the language to conduct something called remote procedure call. Just want to share with you, I talked to one of the faculty members. I didn't say what I'm teaching, but I'm actually talking about general computer science curriculum. And it's very surprised that he asked me, he said that, made the comment without knowing what we're doing here. He said, I wish the student coming to my class really already know what is remote procedure call. So apparently, then I tell him I'm teaching you this. He was really impressed. He said, yeah, that's a very important thing for an advanced course to have that concept to build up. So that's why I want you to learn the concept. What is remote procedure call? And you know how to program. I mean, in computer science or computer engineering, to just know the concept is insufficient. Experience counts a lot. So it's very important for you to understand, not just to get it to work, but you see other people's experience being encoded in the code that you are seeing, such as the code being generated. That is, I really want you to understand every single line of code. That's why I'm willing to spend a lot of time to kind of delay, give you extension, and such that I want to make sure all of you will learn that. Okay, that's my instructional objectives. All right, so I'm going to now, there was a few things I need to work on, but I want to continue on the textbook. We kind of stuck with homework, which is great because homework really lead to the learning more effectively than just reading the textbook. So now I think we spent enough time. Now I want to switch back to talk a little bit more about concept, which I'm going to talk about the chapter 15 now. Now we're going to do chapter 15 to chapter 18. The first one, of course, chapter 15 is exceptional handling. You actually already saw some of that in your homework assignment number 3 and homework assignment number 5 you started. So this is going to be, we're going to go over mainly chapter 15, but we'll also look at JSON C++ library about how they use exception. All right, so what is an exception? You have seen this, like the clause called try. So essentially, exceptional handling in C++ is this 3 keywords, sorry, try and catch. So within the try, the reason for try is that you define the scope where the exception can be generated, and the catch is essentially to describe what we call exceptional handler when those exception situation happen within this curly bracket, pairs of curly bracket, and then whatever it does, it will be catched by the routine. So essentially what you're saying is like this. You have a program, usually when we roll something looks like this. This is called flowchart. Describe your logical thinking about what you're doing. Well, unfortunately, a lot of cases, that flowchart on the left did not include all the situation when you design or when you implement, because there might be new situation, new input. The most commonly occurs situation is that you expect the input should look like this, but then there is some other input which you never consider. That's a possibility, and it basically totally breaks the logic on the left. And therefore, what you want to do is you want to handle those kind of exception situation gracefully or nicely. I use the word gracefully. I mean, in computer science, we use a lot of what we call graceful degradation or graceful handling. Means that you don't want to just give a code breakdown or basically you want to actually fail, but you want to fail nicely. That's what we call a graceful shutdown. And so essentially, exceptional handling trying to do that, and sometimes they can do recovery. So for example, if you think about you're working on this whole system, you catch an exception. And for some of the exception, not all the exception, when you actually trigger the catch clause, what you can do is you can just restart the system. You can restart the system. You say, okay, I save certain state of my data before I crash. And that's called persistent data. You save some persistent data, it crashed. And then you actually restart the whole program. And then you actually try that again. And the other way to do catch, which you're already familiar with, for your homework assignment number 1, number 2, when you send a JSON to the server crash. And after server crash, it's done. But what you should have done in the server side is, number 1, the server can do exceptional handling and basically restart itself, and such that it will automatically regenerate an instance for the client to be able to connect to. That's one level of exceptional handling. But on the client side, you actually don't need to say, oh, you tested 40 times and Professor Wu's server never worked. Don't do that. What you can do is you actually use exception. So whenever you realize that the internet connection failed, you actually write a loop to actually retry that after, say, 20 seconds. And then you retry to do the connection, so you don't have to do that. You just, before you go to sleep or before you start your online video game, you just send that program to run 2 million times until it's successful, okay? Of course, you probably, hopefully, you don't need 20 million times. So let me ask you a question. In programming, how do you actually make a program to go to sleep for 20 seconds and then resume its activity? How will you do that? Yes, there is a Unix system called sleep. You just say sleep 20. That's seconds. Okay, so just to tell you that this is it's a small thing, but it's a very handy for you to deal, because the exception, sometimes you want to control the time a little bit. You just say man sleep. Not this one. This is sleep 1. I want to do sleep 2. I think it is -2. Is that right? No. What is the main command for me to do? Just 2, right? Thank you. Is it sleep 2 or 3? All right, thank you. Oh, okay, got it. Yeah, this is sleep. It's not a system call, it's a library function call. Thank you. So you can just say sleep And over here is a unsigned integer of the seconds. So essentially what it will do is counter there how many seconds you actually put it there. It will just go to sleep mode for whatever number of seconds, and then it will resume. All right. All right, so this is the basic idea of exceptional handling. And now for this lecture, we're going to go through a few interesting cases, so you can actually develop there are three things I want to tell you. The first thing is detection. So there need to be a trigger in the catch clause, in this clause, to trigger this exception to actually generate. So there are cases which is the system will trigger exception. For example, in the JSON CPP, like JSON RPC CPP library, it will have a trigger. For example, the remote lib server, the remote server, HTTPD server is not responding. That will be trigger exception because you ask to the program, you have that condition. Or some of the exception could be there is some parsing error that in the library. So essentially deep in the code, it actually detects certain condition. It will trigger this, this condition. And some of the exception, by the way, is not catchable. I don't think divided by 0 is catch. I have to check on that. I haven't checked that for a while. So there are certain things it might not be catchable or might not be generated exception. And also, there are certain conditions which is related to some library function, such as malloc. For example, when you do a malloc and is allocating a memory which it fails, and essentially that will trigger some exception as well for you to catch. So there are cases which obvious cases that you can actually manipulate. Okay, so the second thing is that we are going to talk about is control flow transfer. Means that how do you actually transfer your control flow? Means that the execution of your program from the left side to the right side. How do you actually, when do you do that? And the more important is how do you actually transfer back? Because once you're in the catch flow, the catch size, and then after you finish, how will you transfer the control back to your original program? So that is another thing we need to learn. I mean, it's not that difficult, but you need to know, otherwise you might confuse, especially when you have a multiple catch clause to actually catch for the same kind of, we'll see that in a minute. Okay, that's number 2. And number 3 is very good. I think the most interesting is probably number 3, is that what information you need to pass from the left side to the right side. Because I'm actually catch an exception. I need to know at least what it is. I need to know what kind of exception I'm dealing with. And with that exception, maybe I will have more information about the detail, the state about my program. So I will have more information I can handle in the catch clause. In fact, I think the third part is probably the most interesting because there are a lot of variety of ways that you can actually handle that. Okay, so now we have this this is basic syntax. You have a try clause, and then you have a catch, try after class, and then in between you have throw. But I do want to say that sometimes the throw might not be immediately between that pair of curly bracket. The throw might be one of the function that's actually being called by the program. That, you know, for example, assuming you're calling a function called get distance. So over here, I have a get distance, but I potentially can generate a throw in the get distance, not in this code, but in the get distance. And such that when get distance throw an exception, And when I call, when I actually call get distance here, then this catch clause might actually catch that one. Okay, so it's not necessarily you always see throw in between the try block. It could be somewhere inside, and sometimes it could be very deep, and sometimes it could be catch multiple times. We'll see those examples. Okay, the first example I want to show you is essentially I have two different catch for the same exception. So you can see that I have a try block. This is essentially a program I wrote for your homework assignment number 4. So I actually try to look for different kind of pointer and try to see whether the pointer is a null pointer or not. I want to do a check. So you can see that I actually have two different throw statement. One is throw null pointer. One is throw text index. So you see that I not only do a throw, but I also provide some information. So I will be able to know what's going on. Okay, so in this example, I have two catch. One is actually the parameter is an integer. One is catch a traditional C string. Okay, C string is essentially character star. If it's C++ string class, it's std : capital S string. Okay, so you probably can guess, right? Which catch block will be triggered by which throw? So the first one is actually basically matched by type. So the first one, null pointer, is a string. So it will match the second catch clause. And the second one is text index, which is an integer. So it will match the first one. So essentially, it's doing something looks like this. Okay, so when you actually hit the null pointer, it actually will trigger whatever you have over here. And remember, I'm talking about control flow transfer. So you have a try with a bunch of this. So if the red was triggered, then you will execute the red part. And after you finish that, you will continue the next statement. Okay, without going back, you will continue the next statement, whatever after the final catch clause in the try. So essentially, you're thinking about one try block of program, and then you have one or more of this catch blocks. And the thing is that after you finish that single exceptional handling, you will start executing the first statement after the last catch block. Okay, is that good? Oh, similarly, if you actually trigger this one, if you trigger this way, you say the text index is equal to this one, and essentially what you have is that it will, of course, trigger the first catch clause, and then after the catch, it will skip the remaining of the catch blocks you might have there, and then start it from the same place. Okay, so now you know the control. Number one, you know control flow already. Now you know it's matching the parameter type and then the information you got passing. Yes, please. I haven't actually talked about that. I will show you an example. Yeah, you could have. I will just give you a very simple example here. For example, if I actually catch this as an integer, right? I can, within that catch, I can actually call a throw, another throw. I can throw and throw with a string. Then this one will actually catch it. you could trigger multiple ones. But I'm going to show you a more complicated situation in JSON RPC. Yeah. Right, the exception will go up. Right, correct. Okay, so I wrote the down here. There is another language construct you might have used it. I think this is even work for C. It's called assert. So assert is also a command that you can actually check whether that condition is true. So the difference between assertion and the exceptional handling is that exceptional handling is just detect a condition and pass that control to a block of code. We call it exceptional handler. And assertion is essentially when you have assert, I'm going to generate a trap. So essentially is generate something that outside the control of your program to let, for example, the system or operating system to handle that kind of trap or even kill or something like that. The program might just die if you have an assertion. So there is a little bit difference between assert and exceptional handling. Exceptional handling, programmers still control. But assertion is basically the programmer does not have control within this program. You have to do it somewhere else outside of this program. Okay. Okay, so I'm going to now introduce if we can pass a single argument like an integer or string. So you can imagine we can pass an object as well. We can actually pass a more complicated stuff, such as an object. We're talking about object-oriented language that we want to do something more complicated. And the thing is that we can certainly do that. And C++ provide a stdException. So it means that they actually create a class called exception. And so the exception will have standard kind of interface for you to pass a much richer type of information that you can include. And then, in fact, it's not only the stdException, but also typically we inherit from the stdException to actually develop, to extend. And some of this using virtual function to be able to handle a much more interesting situation for exception. So let me actually show you some example. Okay, so this is an example for the exception. You can see that I don't have any throw clause. So essentially, this is a exception when you want to create, potentially you want to create an array of 1,000 elements, 1,000 integers. That's my array, right? Integer star, my array is a new int, 1,000. So you essentially create an array of 1,000 integers. And guess what? When you do this, you actually might causing a exception. This exception is a standard exception. Is called bad memory allocation. Means that I try to allocate memory for 1,000 integer, and for some reason it didn't give me the right amount of memory that I needed. For example, memory may be used up by the system. That's pretty much, if your program has a memory leak, then essentially you will have that. So this is going to trigger, and you can see I didn't say throw, and that is a standard. There are two things standard here. Number one, bad allocation is a standard. Means that anytime you allocate, you use the language to try to create some memory using malloc or using new, as actually realize that the memory allocation failed, it will actually generate a bad alloc exception. So essentially what you have is that I just write the code. You see, this is a very generic way of writing exception as a catch, exception reference, and then with an E. Okay, so that basically generated by the memory allocation side. And then within the program, what I did, I could have done other things, but all I did is I said print e.what. So essentially, what we will see that in detail. What is a function of this exceptional class to tell you what happened? What is the case that just triggered? Is this because of the bad memory allocation? Let me just try to show you a picture so you have some better idea. So this is the exception class looks like. This is the basic one. I mean, when you develop program, you will inherit from this class exception. So class exception has, of course, has constructor, destructor, but the only function they provide is a what. And the what, number one, it return a string, return a C string about what is the message you're providing. And then there is a virtual. So it means that when you inherit, when you do this kind of cast back to exception, it will still print whatever you want. That's the virtual function. The power of virtual function is allow people to inherit, and even though you cast back as an exception, it will still execute the what, the virtual function what defined by the extended or derived class. Okay, so this is exception, and this is a standard, all the standard exception that's catched by the basic exception. For example, number one, you see that std back alloc, that's memory allocation, and std back cast, that's for some concept called dynamic casting, and you did that wrong at runtime. Basically, everything here is catch for the what do I call something which you cannot handle at the compiler time. At the runtime, this will be catch. And on the left, you have all kind of arrow, for example, out of range. If you have an array, out of range, you have an overflow, all kind of arrow. That those are the standard that's actually provided by them. Okay. Okay, so essentially, let me summarize this example. So essentially, you didn't see the throw in there, and because any library that within that block of code of try, that's why the code try is important. The try basically limit the scope about the code, including those code that's actually within the library function, within deep down there, multiple layer has anything that's actually generate exception, then essentially this catch clause is going to catch that. Given that within that code, they don't have a exceptional catch already. So think about that. For example, I have a call called getDistance. And inside getDistance, I have a throw. Just assuming I have a throw. So there are two cases. One is that within that getDistance, I have a throw, but I don't have a try and catch. So it means that my getDistance didn't catch that exception it generated. So, okay, this one will actually catch that. Case number one. Case number two is that, well, within that getDistance, I do have try and I do have catch. And that catch actually catch it. Okay, then basically this catch won't get it because somebody already got that within getDistance. All right, so that's case number two. So there is somebody before you can actually reach this catch clause already handle that exception. You don't want to handle that multiple times. That's number two. Case number three is that you do have a try and catch within getDistance, but in the catch clause, it actually throw again. So basically, it's a one throw to one catch. That's pretty much a baseball concept there. So you could have throw and you catch it. After you catch it, you throw again. And then the second throw is going to be generated by whatever the next level catch clause is going to get that. And in that case, maybe this is a catch class. So that's why, answer to your question, you can actually do that any kind of manner you want to have. Okay. All All right, so now you have this. I'm going to show you just some example. Let's see what is the example. This is related to your small program that you're going to write some small program from your textbook. Is actually the source code is on GitHub. You should already have it. So I just wanted to show you this is a very simple program. It's called myTrouble.h. So this one, I'm not even using the standard exception. I'm just writing a class called trouble. But this is in some sense very similar to the exception, the standard exception class. So you can see that in this class trouble, I have a message, which is essentially implement the what. So you can see that I have a string message. Okay, I better not walk too far. And then I have a constructor, basically say, how do I initialize that message? And then I have a what? I just basically return this message, something like that, right? Okay, so, okay, I should actually tell you the syntax, but I want to ask you, I want you to guess, okay? I want you to guess. That's my habit. Without telling you, I want you to guess. What is this statement? This statement, trouble string str is equal to there is a problem, and then colon message str, and then empty pair of curly bracket. What is that statement is doing? Yes. Okay, that's correct. So I want to repeat what you just said. So this is a constructor. So it's used when we construct a trouble object. So when I create a trouble object, if I provide a message, because you can see that this constructor needs one argument, which is a string. If I actually put the string, say, hello world, then that hello world is going to be used as str. It's going to set the message. You see that the message using bracket initialization. So if I have a message different than the default, I mean, if I provide any message, then that message will be used to initialize the message for this trouble object. But if I didn't provide anything, so it means that I'm just calling it with null argument, then it will use there is a problem as a default. Okay, that was just a default message. Okay, great. All right, so I hope you get that. And now this is example how to use that. By the way, this is an example in exceptional, so in chapter 15, number 3. I think it's the third exercise. So take a look at the code. The way we do it is, of course, we include that myTrouble.h, and then I'm just simply write the loop. The program write the loop that will iterate twice. So essentially, the first time it iterate, it actually create a throw statement. A throw statement, which is trouble, but the string, the message is nothing. So essentially, I'm going to use there is a problem as the message. For the second iteration, while I is equal to 1, I'm actually going to have, say, nobody knows the trouble I have seen. Okay, for example, this is what the book has this example. If you have this, then basically is the message will be there. And then I have a catch clause immediately after that. Okay, let me ask you the question. In this code, how many times the catch clause will be called? How many times? So I'm asking about control flow transfer. How many times? Yes, 2 times. Yeah, that's correct. Because you see that I said when you finish the catch clause, your control flow will be the redirect to immediately after the end of the last catch clause, which is here, right? That's the end. That's the end of the catch clause. And therefore, what's the end after that? It's still within the loop. It still have the loop guarded by that for loop. So therefore, it will actually go back to the second time. All right, so this is, just be careful. The one issue, control flow transfer, about when you have a exception or a catch clause, just make sure that after that clause, where it should return to your original program design. And okay, that's number one question. Then I want to ask, then for those two catch clause, for the first one, what should be printed? When you say T.1 exception, for the first time, what will be printed based on this example? Let me actually go back. Show you this is trouble.h. This is somebody else. Anybody else? Yes. There is a problem. That's correct. Thank you. So the first time is going to be because the first throw object, there are actually two trouble objects being created. The first object is there is a problem. So that's why the first time it will say there is a problem, exception column, there is a problem. The second time it will say exception, nobody knows the trouble I haven't seen. Okay, that's good. All right, any question? Any questions? I think right now you should have some idea about doing the three things. When do you trigger the exception? Number two, using throw statement or depending on somebody else code to throw an exception at you. Number two is control flow transfer. I mean, when it finished the clause, the catch clause, where will be the next statement that your program will ask you? That's number two, you need to watch out. Number three is the argument. What kind of argument, including the standard exception. So now we're going to see something which you already familiar with, but you never probably understand. So if you remember, you look at this. This is essentially the code generator for your homework assignment number 3. I never actually touched this part, but at the end, it's actually try to say throw JSON RPC exception. So basically, it's expecting that you're actually getting this result called method. That result is going to be an object. But if it's not an object, and you're going to throw an exception, and that exception is called JSON RPC exception, and then you're going to provide some extra parameter for that. Okay, so let's actually take a look at this. I'm not going to this extremely detailed, but what is JSON RPC exception? What is a JSON RPC column JSON RPC? Not too surprised. That's the way how it's defined. Oh, sorry, it's actually being blocked, so you couldn't see the pass. So if you go to your system, you can actually find that file. Okay, it's very important for us to actually know how things work by going to the place. I mean, when you include JSON RPC / there is a one subdirectory there is called JSON RPC / common. And under common, there is a file called exception.h. So if you look at that file, that exception.h essentially inherit from the standard exception. So it has all the exception, but the thing is that it actually introduced a few more constructor because I feel, the designer of this JSON RPC exception feel that I want to pass more argument. So instead of use the default one, I'm actually going to introduce a few like a code, like a message, or even the JSON object. The third one, you can see that I actually can pass a lot of information with a code, with a message, with an object I want to pass. Go to that. And then, of course, I have this standard, but one of the things you should be watch out is what? What is a virtual function? So essentially, when you actually casting this exception or whatever, you can actually cast this to an exception, the regular standard exception. But whenever I call what, I will be able to dig out all the information in everything that's provided, okay, in the construction. You can see that that construction has, depending, the constructor has a 1, 2, 3. Let me actually check. I forgot how many this one has. This one has 1, 2. This one only have a 2. It doesn't have even the third one, but it used Twostylestring. It used Twostylestring. What is Twostylestring? Twostylestring is a function that's convert a JSON value into a string format. So essentially do a string dump about your JSON value object. That's called Twostylestring. Also very useful object. By the way, I should tell you that I showed this to some of the students last Friday, but I want to show to everybody because this is so useful for you to understand the JSON value object. This is probably also recorded in the video I recorded on Friday afternoon. Friday afternoon after class, I record the code, but I want to do a JSON value CPP. So there is a link. You can just search for JSON value class reference, and inside here, let me just put it down here. This one has a lot of resources about JSON value. JSON value is a core facility for representing all the information that you can manipulate as a C++ programmer to the JSON. This is probably the most commonly used library I use when I did C++ development for JSON. So if you look at, go down here, you have a lot of function. Remember I talk about like you already know as int, as unit, as whatever, as all this value, and is null, is bool. Everything is here. Also has operator overloading for everything. And at the end here, you will see, where's Twostylestring? Did I miss it? My eyes suddenly didn't give me, oh, here. Twostylestring over here. That is a function that's actually allow you to generate a nice output of the JSON for that. All right. So this is a very useful, very handy library for you to use. Okay. Okay, so I hope you get an idea about how you can actually extend a exception from the standard exception, and then you can do the JSON exception. Okay, so for the, I'm going to skip this part. I'm going to tell you the last part, which is now we're going to look at some of the standard. I mean, number one, how do I use this exception in this standard exception class, and how do I actually be able to extract? And as I mentioned earlier, that we have this what function, which is going to be virtual, and it has a bunch of standardized exceptions, such as a bad allocation. I'm going to just show you one example of a bad allocation so you will know what we're talking about. So look at this code. Now, instead of integer 1000, an array of integer 1000, you can see here, I'm actually creating a huge amount of memory, I said new long int, n size times n size. So I'm actually creating a huge, and the reason I did that, I want to test out the memory size of my system. I want to say, well, how big of an array I can create. By the way, this is extremely useful when you want to handle big data. When you do machine learning, you handle millions or billions of records. and you want to run a typical neural network algorithm, you're going to do a matrix that's actually a higher, very, very high dimensionality. And of course, that you're going to create a lot of memory stress to your system. So we're going to actually develop some of the exceptional handling code to see what is the issue we're dealing with here. So here's a result. I just want to show you, I only have 2 minutes. So I want to show you that the code looks like. If you ask you the code, I just provide you. And essentially this is on, I believe this is on my system, on my laptop. I actually captured the output here. Essentially the limit, I'm going to break my system when M size is about 4.2 million. So it's a 4.2 million times 4.2 million. That's how many, and long in is probably 8 bytes on my system. So you can actually imagine that basically generate an exception. Okay, so let's actually look at this. The code, the first one is print the M size. Okay, the M size, and then in the exception, it says inside the exception, standard exception, and now the last line is important, is that when you have an exception, you can call a function called type ID. And type ID is very important. It's actually telling you what kind of standard exception we're dealing with. So look at the code here. It says type ID for the E, for that exception object, and dot name. So it means that when you do that, it's actually give me a std9, std9 bad alloc. So using this line of code, the last line of code, it will be able to tell you why you get this exception. Are you doing a bad dynamic casting, or you're doing out of range, or you're doing memory allocation? So that is a string. In fact, you can actually, based on that information, you decide how you're going to do that. So the way I handle it is that if I actually see that, I'm going to reduce that M size a little bit smaller, right? Because I cannot do 4.2 million. Maybe I can do 2.1 million. So I can actually readjust that and then make sure my program still works with the best amount of memory I can get. Okay, just give me 1 second. I'm going to do. So this middle 3 line, the interesting part is that this middle 3 line, this middle 3 line is not my code. It's actually generated by the malloc. That is a new, but remember I said new is in C++, it's similar to malloc in C. In fact, it's not similar, it's a part of it. So essentially when you do new, it actually triggers a exception that's actually thrown by malloc. So you can see that it's actually saying that the message, this 3 line was generated by the exceptional handling by malloc. And it basically say I cannot allocate the whatever, and the size I'm requesting. You can actually calculate 4.2 million times 4.2 million and then times 8 bytes. See if that's number is similar to this. It's basically a VN. MACH is the machine, VN is virtual memory, map is the map. There is a memory map, which if I have time, I will show you, but definitely you learn the concept of VM map when you go to take a course like ECS 150 to see that how virtual memory is being managed. So this is a very nice way for you to actually start to feeling the memory is there. And then the operating system care, they generate exception. And then basically what it does, it not only do that, they actually tell you the memory address over here. It gives you a lot of information for system programmer to know how they want to handle that. But also very important to let you know that this is actually a rethrow. So essentially this already been caught by a malloc exceptional catcher. And then the catcher is going to throw again. And then you actually catch that with that piece of code exception, okay? All right, so I'm going to stop here, and hopefully I gave you a lot of idea or tool or the way you can use the language. You can actually start writing code, not just your code, but writing your code with exceptional handling, and that sometimes move from a what we call a procedural programming or flowchart programming into something we call event-driven programming. So essentially, what we really talk about exceptional handling is something we call event-driven programming. So all the input output is event. For example, somebody hit your keyboard, that's an event. But also the exception, the condition about your program is also event. And event-driven programming is very interesting, and it will make your code more dynamic and more robust. Okay, so I'm going to stop here. Any last minute question? Okay, so I will be staying outside for answer question, and just remind you, this Wednesday we're going to have an office hour in academic search right after the class. This Wednesday, and until 2 o'clock. And Thursday we're going to do Zoom. Okay. But don't expect the quality of Zoom is too good. I don't like this.
We're not going to go to academic search today?
Yes, we're not going there. Just a moment. Yeah, just